This is section 13.3. We're looking at 30, 60, and 90 triangles. These are some tougher examples. We learned in our last video that if you knew one of the dimensions, you can find the other two. We're going to do the same thing here, except these ones are just a little bit tougher, and you'll see why in a second. This dimension right here is the short leg. Typically, in the easy problems, our short leg is a whole number. If it's not a whole number, you still do the same thing. You still multiply or divide by the square root by 2. And you multiply or divide by the square root of 3. Those are the two numbers that you're going to use. Remember, if we have short leg and we want hypotenuse, we multiply by 2. What is 4 square roots of 3 times 2? Let me just write it out for you so you can see what it looks like. What you're going to do is you're going to pick out the two numbers that look alike. See how the 4 and the 2 don't have radicals? Those are the ones that look alike. Multiply those two together. 4 times 2 is 8. And the square root of 3 just comes along for the ride. 4 square roots of 3 times 2 is 8 square roots of 3. Now, you got to do the same thing with your short leg to find the long leg, except we're going to multiply by the other number, the square root of 3. What is 4 square roots of 3 times the square root of 3? Remember that little trick. Find the two numbers that look alike. See how the square root of 3 and the square root of 3 both have radicals? We know that the square root of 3 times the square root of 3 is just 3. So 4 times 3 is 12. So a little bit of work involved, but there's a pattern here. If you don't recognize it now, you will soon. Let's try number 5. Let's go backwards. They give us the hypotenuse. You want the short leg, so let's divide that by 2. If I have 8 square roots of 6, the short leg's going to be half of that, so it's just going to be 4 square roots of 6. The long leg is going to be that short leg, 4 square roots of 6, times the square root of 3. Okay, now we have a little bit of simplifying to do there. That would be 4 square roots of 18. Let me make some room here. That's got to simplify because the square root of 18 has a perfect square inside of it. And that perfect square is 9. Square root of 9 is just 3. 4 times 3 is 12. And you're multiplying that by the square root of 2. That long leg is 12 square roots of 2. Let's try some other ones. This number 6 is going to look exactly like your number 4. Look at your number 6 again. You see how the long leg is a whole number? Wasn't the long leg a whole number in number 4? Look at the short leg now. If your long leg is 12, your short leg is going to be 4 square roots of 3. If your long leg is 15, your short leg is going to be 5 square roots of 3. The trick is you divide 15 by 3 to get 5, and then you put the square root of 3 on. Okay? Really what we're doing there is we're dividing by the square root of 3, but then we have to rationalize. So remember the whole rationalizing concept? 3 goes into 15 5 times. You're left with 5 square roots of 3. You don't have to do that every time. It's a pattern. Once you see it once, it'll work like that all the time. Okay? So if you didn't catch it on this number 4, hopefully you caught it here in this number 6. Okay? Short leg is 5 square roots of 3. So the hypotenuse would be double that. It would have to be 10 square roots of 3. Number 7. You have the long leg, it's 10 square roots of 6. The short leg is going to be that number, 10 square roots of 6, divided by the square root of 3. Don't make this overly complicated. You can rewrite it like this if it helps you. So your short leg is going to be 10 times, what's the square root of 6 divided by square root of 3? Just the square root of 2. Next time you see that, you think you'd be able to do it a little bit quicker. 10 square roots of 6 divided by square root of 3 is 10 square roots of 2. Okay, now you have the short leg, 10 square roots of 2. Let's multiply that by 2 to get your hypotenuse. It's got to be 20 square roots of 2. So these are tougher. It takes a little bit more thinking, a little bit more work. But once you get used to multiplying radical expressions with other radicals and other numbers, it gets easier. There might be some equilateral triangles in this section. Why? They're not 30, 60, 90 triangles. But if you draw this altitude or this median right here, or that perpendicular bisector, it's all of those segments if you remember, it splits the equilateral triangle into two 30, 60, 90s. Okay, so if you see an equilateral, don't think that it's out of place. It's actually just two 30, 60, 90s pushed together.